Hello and welcome to this Edexcel A-Level Geography Inquiry Question Review. Today we're looking at Water Inquiry Question 2, which is what factors influence the hydrological systems over short-term and long-term timescales? So, as always, first thing we do is we look at the specification. This is so vital as it gives us the key terms that you're likely to see in the exam questions. It also shows us how the different key ideas are linked to the different areas of more detailed content. And also, as we can see with these little world signs here, it shows us the compulsory case studies, the information you're going to have to be expected to give within an exam answer. So if you're looking at explain questions, you may be looking at just one of these sections, section A, B or C, or maybe one or two within one of the key ideas. You may need a small amount of case study detail, but very, very limited in that. However, when you get to the assess or evaluate questions, this is where it may link between different key ideas, or it may link between the different sections within the key ideas, or it could even link to different factors between different inquiry questions as well. So, as ever, always look at the specification when you are reviewing and revising and make sure you understand all of the key terms within it. So moving on to the content then, here we have the overall mind map. And there's three main areas that we need to be looking at today. We're looking at droughts or deficits within the water cycle. We then look at the flooding or the surpluses within it. And then we look on a different timescales, the different impacts of climate change and how this could impact on droughts and flooding in the future. So, looking at droughts or deficits within the water cycle. First of all, it's understanding there are four main types of drought. First of all, we have the meteorological drought. This is where there is a lack of precipitation. So obviously, once you have this lack of precipitation, over time, this is going to lead to deficits within the hydrological cycle. So here we're talking about changes in groundwater, in river flow, in lakes, in reservoirs. Then this is likely, once we have this deficit in the hydrological cycle, it could link or lead to an agricultural drought. This is where farmers are finding it more and more difficult to try and grow the food that is needed because they're having to abstract from deeper and deeper in ground resources, making it harder and harder to produce food or to support cattle for pastoral farming. Now, obviously, if this continues, if there's a lack of rainfall, which is leading to the hydrological drought over a longer period of time, leading to agricultural drought, in many areas, particularly those that are less developed, it could lead to a famine drought of the type that we see in sub-Saharan Africa. So what are the causes of drought? Well, obviously, we have the physical causes. These could be changes in precipitation levels. Now, this might be changes in the frequency or intensity of rainfall. So it may be that although overall amounts of rainfall fall, but it becomes less frequent. So in some areas, instead of having sort of 2 monsoon seasons, which they can rely on for their crops, they may only get one real intense monsoon season, which is going to affect the hydrological cycle and agricultural droughts. We also have these short versus longer term causes as well. So it may be that, we often get droughts every few years, but it could be what leads to these more prolonged experiences of droughts lasting a longer period of time or becoming more frequent in the long term. And we also need to look at the El Nino Southern Oscillation, caused by changes in temperature patterns within the Pacific Ocean, which can lead to El Nino, which can often lead to sort of droughts within the Western Pacific, places like Australia, Indonesia. Although moving into the other side of the cycle, La Nina, which could cause droughts over on South America on the eastern seaboard of the Pacific. But it's also important to realise there are human causes of drought. This could be due to over abstraction, too much water being drawn and not enough rainfall to refill the aquifers. It may be competition from differing sectors. If industry and economic growth is seen as the main drive for the government, then that may reduce water available for human consumption. So there could be droughts within different areas. And the improper use of water as well. In places like the Nile Delta, often the irrigation is very simplistic, and a lot of the water used to irrigate is lost through evapotranspiration. Okay, so although there could be plenty of water if used effectively, because of the misuse of water, that is leading to the impacts. So obviously we can understand the human impacts that droughts will lead to, but also it's understanding what are the impacts on the ecosystems. And these can have a number of different feedbacks. If we look at wetlands, for example, now wetlands are very, very important ecosystems. They help to clean and store the water, and the animal and plant life all work together in a very complicated system to keep that operating. Wetlands are also important in the synoptic links linking to carbon, because the amount of carbon that can be stored in there. And very similar could be said about forests and forest stress. Now, forests do more than just collect carbon dioxide and create oxygen. They are very important for locking in carbon into the soil, putting it into the nutrient cycle and into the food chain. Now, when a drought occurs, these trees can start to die off, which means that then they have a major impact on infiltration rates, on interception rates, but also evapotranspiration rates. So it can actually have a feedback onto the whole of the climate system. And this can be seen particularly in Amazonia. Now, also as these forests start to dry out, it can lead to more forest fires and bushfires, which again can lead to more stresses within the wider area. On the opposite side, we also have more surpluses or flooding. Now, what is important to realise is you can often, with the changes we're likely to see, you will often have flooding and droughts in the same area, but obviously at different times. So, causes of flooding. Obviously, they can be short-term or long-term causes. They could be physical causes, things such as individual storms, monsoons, links to changes in climate and global atmospheric circulation, or different frontal patterns, different jet streams, which could change the nature of heavy or prolonged rainfall events. Changes to pattern of the snowpack and snowmelt can also have a massive impact in the likelihood of flooding in certain areas. Then, of course, we have the main human elements to it. Urbanisation, increase in impermeable surfaces, deforestation, having an impact on many areas of the water cycle and drainage basin. Agricultural techniques can also have an impact, allowing the water to flow off in certain ways by ploughing it in certain ways. That can have a major impact. And mismanagement, protecting some areas without considering the impacts on lower downstream. So again, lots of different causes. Which is the most important? Well, it depends on the area. If you were asked to prioritise these, you would need to make a judgment based on these for assess or evaluate questions. And again, when we're looking at the impacts, we need to look at environmental impacts, the impacts on the ecosystems. Yeah, is it going to lead to crop dieback, the primary producers, which will then have an impact on the whole of the ecosystem with soils? Is it going to leach the nutrients out of the soils, making them less productive, and then having an impact on the ecosystem and net primary productivity again? There are also the socio and economic impacts. And this is important that we look particularly at the UK for either the 2012 or 2015 storm events. Okay, so you need to look at those in detail to have case studies of the impacts of flooding and surpluses. And then we move on to sort of what could happen in the longer term. We look onto the impacts of climate change. Now, with climate change, what we're going to see is the warmer temperatures and changes to the thermohaline circulation and temperatures in the ocean could lead to changes in the global atmospheric circulation. It's that term again from inquiry question 1. Now, this is going to lead to changes in precipitation. It might change in the number of rainfall events. It might change the intensity of the rainfall, meaning you might get fewer rainfall events, but with much more rain falling in a shorter period of time, which is likely to lead to floods. But then, because it's only a short period of rainfall, after the flood is dissipated, it could then lead to a drought, leading to patterns of flood and drought. But this will depend on location, particularly related to latitude. Also, precipitation is the input. For the outputs, evaporation. You could see that more heat leads to more evaporation or evapotranspiration. And because this could lead to forest dieback, this could lead to fewer forests, so it could lead to less evapotranspiration. So in some ways, more heat could lead to more evaporation, might lead to more clouds, it could be reflecting more of the sun's energy. But in other ways, the changes to the ecosystems means there's less water available in the ecosystems for transpiration. This becomes one of the sort of tipping points that we don't actually know until it happens. We can only forecast it. Also, the changes to climate and global atmospheric circulation is going to change the stores and the flows. Between the snowpack and glacier mass, we already know that glaciers are retreating massively. This is massively important for things like mainland Europe, where many of the major rivers are formed in the Alps and the water flows throughout the year from the snowmelt from the Alps. In the Indian subcontinent, looking at the importance of the glaciers in the Himalayas, feeding rivers such as the Indus, the Ganges and the Brahmaputra, for which billions of people rely on. There's also going to be changes in reservoir lakes into the permafrost, where much water is stored within there, and will also have an impact on soil moisture. But the difficulty is, what are the future projections? Climate change is very unpredictable because there are so many different variables. We don't know how governments and people will respond. We only have to look at the changes of the US ideology to climate change, the change from Obama to Trump. We also need to understand there are many varied feedback mechanisms which will feed back into climate change. And not knowing whether it's economic growth, whether it's business as usual, whether countries will work globally to restrict climate change, or whether we become more individual self-serving nations, which will effectively increase climate change. And then we don't know how these feedback mechanisms will work with each other, leading to tipping points that we don't know where that point is. So it's very, very difficult to project the future. We know that it is likely to lead to more extreme events in terms of droughts, but to say where these will happen and how often they will happen is not possible at the moment. This is why it makes it such an interesting topic to study. So overall, here again, we can see how everything links together for inquiry question 2, from the droughts, the deficits in the system, the flooding and the surpluses, and the way that climate change will impact it, but in uncertain ways. So I hope you found this useful. Thank you for listening to Water Cycle Inquiry Question 2. I'll see you again soon. Bye.